Inverse trigonometrical functions. Inverse sine function. Inverse sine function. Let f of x is equal to sin x or y is equal to sin x. Now, putting the values in a graphical representation table, that is, putting xy values in a table, let us see how the graph will be formed. X and y values. Now when x is equal to minus pi, y is equal to 0. X is equal to minus pi by 2, y is equal to minus 1. X is equal to 0, y is equal to 0. X is equal to pi by 4, x is equal to pi by 4, then y is equal to 1 by root 2 or 0.7. When x is equal to pi by 2, y is equal to 1. When x is equal to pi, y is equal to 0. Y is equal to 0. Now, here the value starts in between minus 1 to plus 1. Let us put these values in a mapping. Now, when pi by 2, when sin x is equal to pi by 2, its value is minus 1. When sin x is equal to 0, the value is 0. When sin x is equal to pi by 4, the value is 0.7, that is 1 by root 2. When value is x value is pi by 2, then y value is 1. So this is mapping from A to B. This is sine mapping. Now in the similar way, for the sine inverse mapping, so values, the range values becomes in a domain side. Domain values become a range side. This is the domain side of sin x. This is the range side of sin x. Now substituting the values for sine inverse, substituting the value for sine inverse. When domain side is A, then range become minus pi by 2. When it is 0, When it is 0, then this value is 0. When it is 0.7, 0.7, then this is pi by 4. When this is 1, then this becomes pi by 2. That is here domain of f is equal to R, and range of f is equal to closed interval of -1 and a closed interval of 1. Since this is inverse sine functional mapping. This is inverse side functional mapping. Now this is sine functional mapping. Therefore for y is equal to sin x with domain of f is equal to closed interval of -5 by 2 and closed interval of 5 by 2, and a range of f is equal to -1 to 1. Since it is a 1-to-1 function, then inverse of sine exists, then inverse of sine exists, and denoted as arc sine or sine inverse Now let us see sinusoidal function. Sinusoidal function is a sine function. Sinusoidal function is a sine function. Sinusoidal function for sin x. Now, putting the value of above tabular, we get a graph for sine curve. Between 1 to 1 to minus 1. That is, the values are in between 1 to minus 1. Now putting the values in a xy axis. This is y axis, xy axis. Now the graph starts from 0 to 2 pi, 0 to 2 pi. So from 0 to 1, for y is equal 0 to 1, the graph formation of the graph is like this. This is pi by 2. This is pi. This is 3 pi by 2. This is sinusoidal graph for positive axis of x. Now coming to negative axis of x. We have the graph becomes pi by 2. No. This is minus pi by 2, and this is minus pi, and this side minus 2 pi. Minus 2 pi. Minus 2 pi. Now for sine inverse function, the sine inverse function, the values are lying between minus 1 to 1, based on sine value. Now putting the values in xy axis, that is, this is x axis, x dash, y dash. Now the values start in between minus 1 to plus 1. This is 1, this is minus 1. Now it becomes pi minus plus 5 by 2, minus 5 by 2, minus pi, domain of f is R, and range of f is -1 to 1. Now based on mapping, sine inverse mapping, based on sine inverse mapping, based on sine inverse mapping, based on sine inverse mapping, y is equal to sine inverse x if x is equal to sine y, x is equal to sine y, and y is a element between minus pi by 2 and pi by 2 closed interval, and we conclude that domain of f is equal to, for sine inverse function, is a -1 to 1, and range of f is equal to minus pi by 2. Now second one, inverse cos function. Now let us draw graphical table and graph for cos function. Graphical table and graph for cos function, that is, this is y axis and this is x axis. This is positive side of x and also positive side of y. This is y dash and this is x dash. Now putting the values of cos x in a graphical representation, the values lies in between +1 to -1. So this is a +1 to, this is for -1. Now it becomes this is pi, this is pi by 2, and here 0, minus pi by 2 and minus pi. This is a cos function. This is a cosinusoidal function or cos function. Now considering consider the cosine function. Considering the cosine function f defined by y is equal to cos x, then domain of f is equal to r, range of f is equal to -1 to 1. This is for the cos function. Let us put these values in a mapping. Now we will map first cos function, cos x, cos function. Now A is domain side, B is range for cos function. When x is equal to 0, y is equal to 1. When x is equal to pi by 4, then it is x is equal to, we will take first pi by 3. X is equal to pi by 3, then y is equal to 1 by 2. When x is equal to pi by 4, y is equal to 1 by root 2 or 0.7. When x is equal to pi, y is equal to -1. Similarly, we draw mapping for cos inverse. This is A and this is B. Now 1, this becomes 0. 1 by 2 at domain side becomes pi by 3. 1 by root 2 becomes pi by 4, and -1 becomes 5. That is, the mapping of cos inverse function is a decreasing function between 0 to pi. So we can take decreasing values of a function for mapping. According to mapping, cos inverse function is a decreasing function, and 1-to-1 mapping between 0 pi, that is, a domain of f is equal to -1 to 1, and a range of f is equal to 0 to pi. For this value, cos inverse function exists. Now putting in a graphical manner the above values, that is x and this is y, and this is in between -1 to +1. The function is, this is pi, this is pi, and pi by 2. It's a decreasing and one-to-one function. Therefore, since it is a decreasing from -1 to 1 for 0 to pi, therefore cos inverse exists. So we conclude that domain of f is -1 to 1 and the range of f is equal to 0 comma pi. Range of f is equal to 0 comma 5. Third one, inverse tan function. Inverse tan function consider the tangent function fx is equal to tan x or y is equal to tan x. Therefore, df domain of f is equal to R and a range of f is also equal to R, a real number. Obviously, now let us represent a tan inverse function in a graphical manner. This is y axis, this is x axis, and here it is this is pi by 2, and this is minus pi by 2. Now draw a parallel lines along x-axis, but both 5 by 2 and minus 5 by 2. Then the tan values lies in between the given two trigonometrical angles. Obviously here f is not a one-to-one function. F is not a one-to-one function, but if we restrict the domain, if we restrict the domain to open interval minus pi by 2 to open interval pi by 2, then f is one-to-one function. F is a one-to-one function. So it has increasing function and called inverse and called inverse tangent denoted as tan inverse. The value of y satisfying minus pi by 2 y less than or equal to minus 5 by 2, then 5 by 2. That is, y is an element of closed interval minus 5 by 2 and 5 by 2, closed interval 5 by 2, and this is known as principal value of function. Principal value of tan inverse function. Now, fourth one. Inverse cotangent function. Inverse cotangent function. Let y is equal to cot x, y is equal to cot x. Domain of f is equal to R. Domain of f is equal to R, and range of f is equal to R. Obviously f is not one-to-one function. F is not a one-to-one function. According to graph, f is not one-to-one function. According to graph, y x this is pi value, pi 0 to pi, 0 to pi, pi by 2. Pi by 2. So obviously f is not one-to-one function because it is not touching pi value at infinity. Also it failures at its failures at minus infinity, and because it fails to meet, it means graph fails to meet at close interval of minus infinity and plus infinity. Close interval of plus infinity, when you restricted to open interval of 0 and open interval of pi, then f is one-to-one function. So inverse of cot exists and denote as cot inverse. Now y is equal to cot inverse of x if x is equal to cot y and x is equal to cot y and y is a element between open interval of 0 and open interval of pi. Fifth one, secant function. Secant function, sec or secant function. Secant function, let f of x is equal to sec x or y is equal to sec x, then domain of f is equal to R and range of f is equal to minus infinity to minus 1 union minus 1 and union. It is range of f is equal to closed interval of minus infinity to closed interval of minus infinity to range of f is equal to open interval of minus infinity to closed interval of minus 1 union closed interval of plus 1 to infinity, open interval of infinity. Now putting the variables in xy axis, putting the variables in xy axis, we have 0, pi by 2, 0, pi by 2, minus pi by 2, minus pi by 2, pi, this is y, this is x. Now secant graph, the formation of secant graph is like this. Formation of secant graph is one, this is 1, this is 1 and this is minus 1. Now the graph become this like this. This is one here, and the similar way graph for other side is become like this. Now here f is not one-to-one function. F is not one-to-one function, but if we restrict the domain to open interval 0 pi by 2, open interval pi by 2 of closed interval union closed interval of pi by 2 to pi, closed interval of open interval of pi by 2 to pi. Then f is one-to-one function, therefore its inverse exists and denotes as sec inverse. Now y is equal to sec x, x is equal to secant to sec y if y is a element of closed interval 0 and open interval pi by 2 union open interval pi by 2 closed interval pi. For this value y is exists, the value of y in 0 comma pi except pi by 2 are known as principal values of sec inverse x. Please subscribe.